Hi everyone, welcome to the video on solving polynomials by factoring. Factoring is something that we've been working on for a long time. We should be pretty familiar with it. We just might need to factor more than once in one of these problems. To begin with, I want us to know that whenever we're solving a polynomial equation, we're going to know exactly how many solutions it has. So let's fill in this sentence here. It says an nth degree polynomial equation has, we're going to fill that in with n solutions. So I'm going to write an example down here. A quartic equation, which has a degree of 4, has 4 solutions. So I'm going to know exactly how many solutions I'm looking for so that when I'm finished, I'll be able to say I'm either finished or not finished. So our first example, we have a cubic equation. So because this is a degree of 3, I know that this must have 3 solutions. Now it's time to find them. So we're going to solve these by factoring. And the first thing that we want to do, let's write some steps down over here, is to set the equation equal to 0. So to do that, I'm going to subtract a 28x from both sides. So now that became 2x cubed minus 10x squared minus 28x equals 0. Next, we're going to find out what the GCF is. So if I look at all of my terms, I'm going to find out what they have in common. These terms all have a factor of 2, but they also have a factor of x. So our GCF would be 2x. And when I factor out the 2x, I'm left with an x squared minus 5x minus 14. Next, I'm going to factor any quadratic expressions that I have. Sometimes they're going to be factorable, sometimes not. So I'm going to say if possible. So here I have a quadratic x squared minus 5x minus 14. That one actually is factorable. We still have the 2x in front. And this quadratic factors into x minus 7 and x plus 2. Once everything has been factored, now we set each factor equal to 0 and solve for x. So let's start with the 2x. Let's set that equal to 0. And when we divide both sides by 2, we get 0. So we have one solution so far of the 3 that we're looking for. Next, we have x minus 7 equals 0. I add 7 to both sides, and we get 7 for the second solution. And to finish it up, we'll set x plus 2 equal to 0, subtract 2 on both sides, and the third and final solution is x equals negative 2. So we're going to follow these directions for the next 2 problems. So the first direction said set the equation equal to 0. Well, this one's already equal to 0, so that step's done. The next step says to find the GCF and factor it out. This GCF is going to be 3, but an x squared, because both of these terms have a factor of x squared. Let's factor that out. That would leave us with an x squared for the first term and a negative 9 for the second term. All right, on to our third step. We're going to factor any quadratic expressions that we have. Now this x squared minus 9, we could say that it's missing a 0x right there in the middle if that helps us. And then we might realize that that is actually factorable. So we still have the 3x squared. And this time we're looking for numbers that multiply to -9 and add to 0. So those numbers would be -3 and +3. Now that it's factored, we're going to set each factor equal to 0. Okay, so 3x squared set equal to 0. If I solve for x, I would divide by 3. I'd still get x squared equals 0. And then I would take the square root. When you take the square root, you get two answers. You get the positive and negative version. But 0 isn't positive or negative. So what this is really telling us is that we found two solutions at the same time. So x equals 0, but I'm going to make a little note here that it has a multiplicity of 2. Now, I didn't write this down at the beginning, but we might as well think about it now. This was a quartic. The degree was 4. So we know that there has to be a total of 4 solutions, and we have just found 2 of those. The other 2 are going to come from these other factors, right? We're going to get that x equals 3, and an x equals -3. So even though I only have 3 boxes here, right, that 0 counts as 2 of the solutions. All right, one more problem. First step was to make sure it equals 0. Check, that's done. Next step is to factor out a GCF. This is somewhat already factored. I would say that there is not a GCF to factor out. And then the third step is to factor the quadratic. The problem here is that we would need numbers that multiply to 5 and add up to 3. And I can't think of any numbers that would do that. So if we can't factor it, we're still going to have to solve this quadratic equation. I'm going to set that factor equal to 0. And we do have a method that always works for solving quadratics, and that's the quadratic formula. So I'm going to plug in to the quadratic formula. That would be x equals -b, so that's -3, plus or minus the square root. And inside the square root, we have a b squared, so that's 3 squared, minus 4 times a, in this case is 1, times c, which is 5. Then all of that stuff is over 2a, so I'll say 2 times 1. Now I'm just going to simplify. So let's do the stuff inside the square root. Remember, that's called the discriminant. We get 9 minus 20. And this bottom here, we get a 2. And over here, we get -3 plus or minus the square root of -11 over 2 as our final solution to that quadratic. Right? That plus or minus is telling us that we have 2 solutions. So these solutions happen to be non-real because we have the square root of a negative number. That's the 2 solutions for the quadratic, but over here we have another factor which tells us that -2 is also an answer. So if this equation had started out in standard form, it would have been a cubic, and that's why we have 3 solutions. One of them is real, and 2 of them are non-real. So that might be one of the questions we ask. All right, you got some practice on the back. Try those out, and we'll talk about them in class.